Alright, so in this lesson we're going to be looking at factorising monic quadratic trinomials, and you don't need to be too concerned about the title. It looks big and ominous, but actually all it's going to do is looking at quadratic expressions which take the form of something like ax squared plus bx plus c. That's what a quadratic is. The monic means that the value of a is 1, and the trinomial just indicates that there are 3 parts to this expression. Okay, so if we have a look at a question from exercise 8c in the Year 10 textbook, we'll be looking at question 4. Now to start with question 4a, we have this particular question. We've got x squared plus 7x plus 6, and we have to factorise that. We're going to use a method called the PSF method. There are many different ways to factorise quadratic expressions, but this is one sure, secure way of factorising expressions that will get you through very difficult expressions and very easy ones. There are other methods that can be used, and I'll show you some of those as we continue through the course. Right, so the PSF method, we start off by just writing a P and an S and an F immediately underneath the expression. Now the P stands for product. We're looking for a product here. The S stands for a sum, and the F stands for factors. The parts that are going to make up the product are the x squared and the 6. So when I take the product of x squared and 6, I'll get 6x squared. The sum is just this term that's in the middle. That's the 7x. So the sum will be 7x. Now what we need to do is we need to split that 7x up into 2 parts. 2 things that will add together to make 7x. So it could possibly be, we could have 3x and 4x, they add together to give 7x. We could have 2x and 5x, and we could have x and 6x. Now what we need is two terms that will add together to give 7x, but will multiply to give 6x squared. And so very clearly the one that we want is this last one, which is going to be x and 6x. So the factors that we're looking for are x and 6x. So the whole purpose of the PSF method is to split up this 7x, is to try and split that up into 2 separate elements. What we do is we start writing out the original expression again, but now we've split up the 7x into an x and plus 6x, and then finally we've got the plus 6 at the end. Now, last thing to do is to go through the process of factorising this expression. So if I look at the first 2 terms, and I find a common factor there, common factor of terms, when I take out that common factor of x, what I'm left with is x plus 1. Now if I look at the second 2 terms, I'm going to take out the common factor, and the common factor here is 6. After I've taken out the common factor of 6, I'll end up having x plus 1 again. And now you'll be able to see that there's actually a common factor in both of these terms here, and the common factor is actually x plus 1, and once I take out that common factor of x plus 1, then what I'm left with is x plus 6. So now we've managed to factorise the original expression x squared plus 7x plus 6, and we have its factorisation is x plus 1 and x plus 6. But we're going to do 4g, and if we look at 4g, we've got x squared plus 5x minus 6. Okay, same process, we go P, S and F. The product is going to be of x squared and minus 6. So the product is going to give us minus 6x squared. The sum is going to be plus 5x, so we'll put 5x there. And now what we need is 2 numbers that will add together to give 5x, but multiply together to give minus 6x squared. And what's left over, once we've taken out that common factor of x minus 1, is x plus 6. Alright, so that's a slightly harder one. Question 4. for m, if I had minus 2x and minus 5x, well, pretty clearly, minus 2 times minus 5 will give me 10, and x times x is x squared. And if I add these two terms together, then that will give me minus 7x.
Those x's are weird.
So the two terms I'm
Yeah, the reason why we do x's like that in senior school is so that you don't get them mixed up with multiplication signs.
Now split up the minus 7x.
Well, not they are normal x's. It's just that you don't want to get them mixed up with multiplication signs.
And add 10.
They are not normal.
And now if we go get a factor of the first two terms, we'll have x outside of x minus 2. Now the truth is, this is only going to work if this x minus 2 shows up again. So as soon as you've found out what that element is that's in the brackets, you know that this has got to show up again. It's got to be x minus 2 again here. If that doesn't show up again, then the whole thing will fall in a heap. So we have to have that. And what we need to have in order to get the minus 5x and the plus 10, we need to multiply all of that by minus 5. So what we have now is, looking at this, we can further find common factors of x minus 2 in both terms, and what's left over is x minus 5. And so when we factorize this initial expression, we're going to have x minus 2 in one set of brackets and x minus 5 in the second set of brackets. What I'd like you to do is to have a go at some more examples of this from your textbook.